The Drake equation, estimating the odds of alien civilizations. The question. For as long as humans have looked at the stars, one question has followed us. Are we alone? Hello and welcome to Astrobitica, your home for space news and information. Here we turn the vast questions of the cosmos into stories you can understand, remember, and share. So before we begin, make sure to subscribe and tap the notification bell so you never miss a journey through the universe. We've found thousands of planets orbiting other stars, some that might even resemble Earth, but we still have no direct evidence of life beyond our own world. In 1961, an astronomer named Frank Drake tried to frame that mystery in a new way, not as philosophy or speculation, but as a scientific question. He wrote down an equation, not to solve it, but to start a conversation. The simple equation has become one of the most profound tools in all of astronomy. It's called the Drake equation, and it asks, how many intelligent civilizations might exist in our galaxy right now? Breaking down the equation. The Drake equation looks like this. Each term represents a step from raw starlight to intelligent life capable of communication. Let's walk through it. R star, the rate of star formation. First is R star, the average rate at which new stars form in our galaxy. The Milky Way gives birth to about 1 to 3 new stars per year. That may not sound like much, but over billions of years, it's enough to fill the sky with hundreds of billions of suns. F sub p, the fraction of stars with planets. When Drake first proposed his equation, we didn't know this number at all. Today, thanks to missions like Kepler and TESS, we know it's close to 1. Planets are not rare. They are practically universal. Almost every star has at least one planet. N sub e, the number of habitable planets per system. Then we have N sub e, the average number of planets per system that could support life. This doesn't mean they do have life, only that the conditions might allow it. In our solar system, that list once included Earth alone. Now we look at Mars, Europa, Enceladus, and even Titan as possible environments for life's chemistry. Extrapolating across the galaxy, scientists estimate that roughly 1 in 5 stars may have an Earth-sized planet in its habitable zone. So already, with just these 3 terms, the Milky Way could host tens of billions of potentially habitable worlds. F sub L, the fraction where life actually appears. The fraction of those worlds where life actually begins. Here, things get uncertain. We have one data point, Earth. We know that life arose here very quickly, within a few hundred million years after the planet cooled. That suggests life may emerge easily whenever conditions are right. But it could also mean we're lucky, a cosmic accident that happened once and may never happen again. Without another example, we can't know whether life is common or vanishingly rare. Then comes F sub I, the fraction of living worlds that produce intelligent beings. On Earth, simple life persisted for nearly 3 billion years before intelligence arose. If evolution were rewound and played again, would intelligence reappear? Maybe yes. Maybe consciousness is a natural adaptation once complexity reaches a threshold. Or maybe intelligence is an evolutionary fluke, one that serves no real advantage in the long run. Again, we don't know, but that uncertainty is part of the equation's beauty. It exposes how little we truly understand about life's trajectory. The next term, F sub c, represents civilizations that develop technology capable of signaling their existence across space, radio, lasers, or something more advanced. Humanity has been broadcasting just over a century, a blink of cosmic time. Our signals have traveled barely 100 light years, a tiny bubble in a galaxy 100,000 light years wide. If other civilizations are as short-lived or as quiet as we've been, they would be nearly impossible to detect. Finally, there's L, how long those civilizations last. This might be the most important and most sobering variable of all. If advanced societies destroy themselves through war, resource collapse, or technological catastrophe, L could be short, decades, maybe centuries. If they survive, learn, and endure, L could stretch for millions of years. Multiply a large L by billions of stars, and the galaxy could be buzzing with signals. But if L is small, we might truly be alone, separated not by distance, but by time, civilizations blinking in and out before ever overlapping. What the numbers tell us. Over the years, scientists have tried plugging in estimates. Some versions predict thousands of communicating civilizations in the Milky Way. Others yield numbers less than one, meaning we could be the first. The point isn't the answer. The point is how each term reflects a fundamental mystery about stars, planets, biology, intelligence, and the future of technology itself. The Drake equation isn't a formula to calculate aliens. It's a framework to understand what we still don't know. The search today. Today, the equation drives real science. Astronomers search for biosignatures, oxygen, methane, water vapor, and exoplanet atmospheres. Projects like SETI listen for narrowband radio signals that could indicate artificial transmission. The James Webb Space Telescope is already characterizing the air of distant worlds, looking for chemistry that can't be explained by geology alone. And new observatories, like the proposed Habitable Worlds Observatory, may soon detect the faint light of an Earth-like planet directly. Every discovery, every rocky world, every trace of water, every molecule of oxygen fills in another term of the equation. So what does the Drake equation really tell us? It tells us that the question, are we alone, is not just philosophical. It's measurable, testable, and perhaps answerable. It shows that even if we never receive a signal, the search itself defines what it means to be human, curious, persistent, unwilling to stop asking questions about our place in the cosmos. And maybe that's the deeper message. If the universe is teeming with life, then we are part of a grand shared story, countless minds under countless suns. But if we are alone, then life on Earth becomes infinitely precious, a spark of consciousness in a vast, silent sea. Either way, the result is awe-inspiring. We exist in a galaxy of 400 billion stars, surrounded by possibilities we can scarcely imagine. The Drake equation reminds us that we are not just observers of the universe. We are one of its experiments in awareness, asking the oldest question with new tools and better eyes. If you learned something new today, give this video a thumbs up, subscribe to Astrobitica, and tap the bell so you never miss our next journey through space and science. Until next time, keep looking up and stay curious.